Good morning, students. Good morning. Am I audible? Voice clear? Okay. ठीक है. So by this time we have discussed up to which part? We have completed the very good morning, Durga Prasad. Very good morning to all. I hope you people are doing well at home and you are working hard apart from enjoying the good food. Very good morning. Very good morning. So by this time we have completed the ionic bonds, and in that we have discussed lattice energy concept, then Pajan's rule. ठीक. Then last class we have discussed covalent bond. Several models are there. First such model is octet rule, Lewis octet rule. ठीक है. So by this point you have done. Page number also I am saying simultaneously which pages you will read after the class. So any questions firstly you want to ask up to Lewis model? I think Lewis model all completed. Lewis model, except the structures we will cover after completing the hybridization and other models. Then at the end we can go for this one. ठीक है. Any question you want to ask? Any questions from your side? Any paragraph, any point you want to ask? So this is completed. What was the last part? We have done the all exceptions. All exceptions. Solubility questions are not in this. No? Solubility in this chemical bonding. You will do in the S block separately. Okay. So, solubility concept is not here. In the block chemistry, you will discuss them. In hydration enthalpy, then solubility concept. Page 106 में last paragraph. Page 106 में last paragraph. Last paragraph, left one or right one? Sesagri, you can go through thermal stability when you get the module. Now you can go through the applications of lattice enthalpy. Then you can get that, or in the S block again you will get that one. That whenever more ionic character is there, it will be more thermally stable. So that you will get by the S block separately. In the S block, it will be clubbed with the lattice enthalpy easily. Sorry, it will be clubbed with the ionic character also. Yes. Thermal stability directly proportional to the ionic character, then carbonate stability you will understand. Now, Ananya asked the doubt from this paragraph. Now, in this paragraph, the point is the ionic solids. 1 minute, it is remote. Remote. AC remote. In this paragraph, it is giving that ionic solid. We have done that point that whenever compound is formed, in that bond formation process, bond formation, that is exothermic, then we say system has less energy, more stable. Same concept apply here. In the ionic solid formation, more is the energy released. During the bond formation, more is the stability of the compound. More is the stability of the compound. So in this case, NCERT has explained three factors are responsible for the overall ionic solid formation. One is that ionization enthalpy that we have discussed already. Sodium is there, it is going from Na to Na plus, which is given here. Second term with chlorine is chlorine going from neutral to Cl minus, electron gain enthalpy. Third term is when the ions are combining and 1 mole of solid is formed. This is termed as lattice energy. Three terms are given. Now here what is mentioned? Sum of electron gain enthalpy and ionization enthalpy. This may be endothermic. Like values are given. Plus 495, yes, and electron gain enthalpy minus 348. When you add them, approximately you are getting suppose around 100 plus 100 kilojoule. That means it is endothermic, positive value. But what is required overall for stabilization? More energy should be released. Hence, if you observe, after summation of these two energy values, you are getting plus, it means endo. Getting it positive. But if you see here, lattice enthalpy released how much? Minus 788. So 100 plus and minus 788 is still minus 600. You can approximately say high energy release. That release in the energy stabilize the ionic compound. That is why it is given here that enthalpy and electron gain enthalpy and IE may be positive, but the crystal is getting stabilized due to energy released in the form of which one? Lattice energy. That is how much released, and therefore the energy released in the process is more than the energy absorbed, and that stabilizing the crystal. Getting Ananya the reasoning or explanation of this paragraph? ठीक है. Now Ramya, NAF and Na2O go by the charge factor. Whenever charge and size they are contradicting each other, preference for charge goes, so O minus 2 will be preferred as compared to F minus 1. Getting Ramya? ठीक है. That is how we get the answers. By everything we know that observation, that which is having more ionic character and which has less, then we can, or which has more lattice energy. So firstly we know the values point, then explanations are framed which factor is dominating. Clear? You are discussing with a subject which is purely experimental based, then theories can be framed. So many theories are there, somewhere applicable, somewhere other applicable. When charge same, then size factor we can go for NAF and NaCl. F minus smaller, Cl minus bigger. Then you can apply the concept as per the size. Sesri, yes, chances are less. In these exams you will not get. In the module if you get, then you have to read the theory of module. Then you will get the question. Clear? So by this time we have done the covalent bond, in which in covalent bonds one model we have done octet rule. We have not discussed Lewis dot structures. At the end later on we will do, and formal charge also later on with dot structure. Only we have done bond formed, octet rule, they try to follow, and drawbacks. Now next part is page 117 onwards. Page 117 onwards. Next model is valence bond theory. After that we will do different models. Page number I keep on mentioning so that you can read those pages after the class also. So you will read after this From page number 117 on 118 graph is given that we will discuss today, 119 and 120. So next discussion is of valence bond theory. Valence bond theory. Syllabus will be shared in the group. Today evening they will share the syllabus, so no need to worry. Now valence bond theory, when you read it, read completely, line by line, but here we are discussing the key points of VBT. In valence bond theory, what is the basis of valence bond theory or VBT model? What is the basis of VBT? Which concept they have given? ठीक है, some are saying explains geometry. Okay. These are chemical bond, ultimately covalent bond formation. These models explains the bond formation. Very good. So write down in the notes the idea that, very good, Josna said rightly, the idea that bonds are formed, the idea that bonds are formed by the overlap of atomic orbitals, by the overlap of atomic orbitals, by overlap of atomic orbitals is basis of VBT, is basis of VBT. Written. Formal charge, formal charge is not there. Already said na, Lewis dot structure and formal charge not there. Whichever in done in class, that is there. Now, what is the graph given there? It is given for hydrogen molecule. On page 118 it is given. Graph, it is the normal potential energy diagram is given. This is given here that for hydrogen atoms, when they combine, hydrogen molecule is formed. So here, this is given. Here, atoms are far apart. When atoms are far apart, there is no force of attraction among them. But when we say the bonds are formed, it means they starts approaching each other. It starts approaching each other. And what happens as they comes closer? As they comes closer, energy or overlapping starts. Yes, that is why bonds are formed by overlap of atomic orbitals. So when they come closer, net attractive forces are dominating. Net attractive forces are dominating, and a point will come, a stage will be reached where there is a maximum overlap takes place between the orbitals. What is taking place? Maximum overlap taking place, and this point is termed as, this point where energy of the system is minimum, this distance is termed as bond length. It is bond length of the molecule where maximum attraction, least potential energy of the system. ठीक है? Again, I am repeating, again saying that one. When atom starts approaching, overlap starts, energy starts releasing because bond formation overall is a exothermic. So the attractive forces are dominating as compared to repulsive forces, and a point is reached where there is a maximum overlap. In that, the distance between the two nuclei where potential energy is minimum is termed as bond length, and the energy released during this bond formation is termed as bond energy or bond enthalpy. आई बात समझ में? Copy this either from the NCERT, you can draw this one, it is same, no difference. ठीक है, तो now here what are the attractive forces working? Then we can write bond length, meaning atoms given A, nucleus, electrons of A, B, electrons of B. In this case, attractive forces will be attractive forces, nucleus of A attracting electrons of A. It is already there, nucleus of A attracting its own electrons. It is one such attractive force. Second is nucleus of B attracting its own electrons. Third, nucleus of A attracting the electrons of B. This one. Fourth possibility, nucleus of B attracting electrons of A. These are the total attractive forces. Similarly, repulsive forces. Repulsive forces which taking place, nucleus of A positively charged and nucleus of B positively charged, they are repelling each other. This is one such repulsive force, and second repulsive force is electrons of A repelling electrons of B. Yes, so these are the net forces attractive and these are net repulsive. And when we say bond is formed, which forces dominate? Attractive forces dominate. So you can mention that one line here. Written. So write down. When bond is formed, net attractive forces dominated over repulsive forces. When bond is formed, net attractive forces dominated over repulsive forces. ठीक है? Then write down the distance between nuclei of two atoms, the distance between nuclei of two atoms In a covalent bond, in a covalent bond, in a covalent bond where potential energy is minimum, where potential energy is minimum, is termed as bond length, is termed as bond length, and the energy released and the energy released during this bond formation and the energy released during this bond formation is known as bond energy, is known as bond energy or bond enthalpy. ठीक है, then write down the key points of VBT. Write down key points of VBT. First point, a covalent bond is formed. A covalent bond is formed. A covalent bond is formed by the partial overlap, is formed by the partial overlap of atomic orbitals, by the partial overlap of atomic orbitals resulting into pairing up of electrons, resulting into pairing up of electrons, resulting into pairing up of electrons. Like if s orbital is combining, ठीक है, when we say orbital combining means the orbitals which are half filled, which contains electrons, they are combining, like these two, like these two orbitals are there. When they combine, we can show it like this, or a shaded region. Getting it? So this is the meaning of the covalent bond is formed by the partial overlapping of the atomic orbitals, and in these atomic orbitals electrons are present in the opposite spin. When they combine in one orbital, there will be two electrons with opposite spin. So this is the meaning of covalent bond formation. That is the meaning of the covalent bond formation, where partial overlap of the atomic orbitals takes place. Take then second point. Second point. as the extent of overlap increases, as the extent of overlap increases, as the extent of overlap increases, strength of bond also increases. As the extent of overlap increases, strength of bond also increases. Now, in this part, we have to compare extent of overlap. What are the possibilities in overlap? S orbital with S orbital. ठीक है, along the internuclear axis all. S orbital with P orbital. P orbital is along the axis. S orbital तो always there. S orbital तो always along the axis. Why? It is non-directional in nature. So whether you take x axis, y or z, S is spherically symmetrical. It will always be some part, or it will always be in the along the axis. 1/3 in x, 1/3 in y, 1/3 in z. So among these, and other one is along the axis p orbital. Now tell me, among them where the maximum extent of overlap is there? Already mentioned along the axis here. This is along the axis, it is along the axis, it is along the axis. Which is maximum overlap? Very good. Lot of students are saying PP overlap, some saying SS. Okay, how many of you can explain also? Like Shranya, can you explain? SK Anwar, can you explain? Niharika, Dadi Peta, can you explain why Gautami, PP? Why PP overlap maximum along the axis? Okay, one reason came same bond line notation, head-on overlap, double bond. Any other reason why? Answer correct. Answer is correct. Half-filled p orbitals. Yes, half-filled orbitals. So we all take for the bond formation, na? So when bond is forming, overlap is taking place. They are all half-filled, no doubt. Yes. Now, by this time you have tried, one student said it is more closer, yes, maximum space. Very good, this is also correct. Understand one thing, S orbital is spherically symmetrical, non-directional. P orbital is which nature? Directional nature. If you say Px, directional you are saying along x-axis, complete lobes are there, है ना? So here these p orbitals are along the axis, means their electron density is maximum along the axis. Why they are along the axis given? So when overlap takes place, it will be also maximum because of more electron density present along the axis. That axis may be z, maybe y, maybe x. But if nothing is given, it is assumed that z axis is internuclear axis. ठीक है? So p orbitals being directional in nature, they have more electron density or more diffused electron clouds along the axis. So when they overlap, the extent of overlap is maximum. So therefore the order is pp overlap, sp, ss, where principal value, value of n, value of principal quantum number should be same, like it is 2s 2s overlap, 2s 2p, 3p 3p. That is the meaning of same value of n. Clear this point? Now write down third point. Third point, extracting from which page of NCERT? Page 120. Sigma and pi bond formation given. ठीक है? Sigma and pi bond, so that you can read after the class. Sigma bond, yes, the reason is because p orbitals along the axis, that means firstly p orbitals directional in nature. So if they are along the axis, maximum electron density between the two nucleuses. More electron or more diffused electron clouds along the axis, more easily or more extent of overlap. Now third point is sigma bond. Sigma bond में how it is formed, by which overlap? Head on overlap or axial overlap. So write down that when overlap takes place, along the internuclear axis, when overlap takes place along the internuclear axis, known as head on or axial overlap, known as head on or axial overlap, results into sigma bond formation. Results into sigma bond formation. Results into sigma bond formation. Clear? So now here, what's the point? The point is sigma bond is formed how? When the atomic orbitals are combining in such a way, they are overlapping along the axis, which is known as head-on overlap or axial overlap. And that type of overlap results into which bond formed? Sigma bond formed. Which example we can take? SS overlap. Whenever s orbitals are involved, remember they participate only in sigma bond. S orbitals never go beyond that. It is not going to form any pi bond. So SS orbitals always sigma bond. Then sp orbitals along the axis if they are combining. Along the axis they are combining. This is termed as again sigma bond formation. Clear? So s orbitals undergoes which orbital, which formation only? Sigma bond only. P orbital can participate in both depending upon along the axis or perpendicular to the axis. So here, third possibility is PP, but it is which overlap? It is head on along the axis. This is along the axis, head on overlap, and this is termed as sigma bond formation. This is known as which overlap? Axial or head on overlap. And this forms which bond? Sigma bond. Up to this part clear? That how in VBT it is explained, sigma bond formation given on page 120. Written. Then next is pi bond formation. Next you can write pi bond. How it is formed? Pi bond. When overlap takes place. When overlap takes place perpendicular to the internuclear axis. Overlap takes place perpendicular to the internuclear axis. Perpendicular to the internuclear axis, known as lateral overlap or sideways overlap. Lateral or sideways overlap. Lateral overlap or sideways overlap results into pi bond formation. Results into pi bond formation. Results into pi bond formation. Written. So, which orbitals will be used for pi bond formation? We can use p orbitals, not s orbitals. In NCERT, they have explained only sigma and pi bond. Other form of bond like delta or phi, they have nowhere used. So even if you read anywhere, it is not explained, it is not given in the structure form. You can leave those other information. So here p orbitals. So what is the condition? That p orbital has to be perpendicular to the internuclear axis. So it is internuclear axis, suppose. And other perpendicular possibilities are this one. It may be px px or it may be py py, assuming z as the internuclear axis. Sideways, you can say sidewise overlap, both same. So that is the meaning of pi bond in which sideways or lateral overlap takes place between the atomic orbitals. If Z is the internuclear axis, if Z is the internuclear axis, then Px, Py definitely will be perpendicular to the internuclear axis, and when Px, Px overlap lateral, it is pi bond, Py, Py, pi bond. But Pz, Pz will be sigma bond. बोलो आया समझ में? Written also, drawn also these orbital diagrams. Then after pi, fifth, write down fifth. In fifth, write down sigma bond sigma bond is stronger than pi bond. Sigma bond is stronger than pi bond. Now, any one of you getting the reason? Any one of you remember the reason why sigma bond is stronger than pi bond? Think about it fast. Let us see how many able to recall last year you have gone through this part. Sigma bond is stronger than pi bond because, yes, very good, Gautami. It is that reason only. Overlapping extent of overlap is more. Very good, Manish. More density. Write down because extent of overlap is more in sigma bond. Because extent of overlap is more in which bond? Sigma bond. And whenever extent of overlap is more, strength of bond will be more. That is why sigma bond is stronger than pi bond. ठीक है, written that point. Yeah, ultimately when we say extent of overlap more, it covers all the other factors like more electron density is there. ठीक है ना? Then general term, if you all know also, but still mention, between two atoms, first bond is always more stable bond, which is sigma. So write down, between two atoms, first bond is, between two atoms, first bond is a sigma bond. Between two atoms, first bond is a sigma bond. First bond is a sigma bond, and if more bonds are formed, and if more bonds are formed between them, and if more bonds are formed between them, they will be pi bonds. They will be pi bonds. Written. So generally we say whenever between two atoms one bond is there, it is sigma. If two bonds are there, one sigma, other will be pi. If between the same two atoms three bonds are there, one sigma, two pi. You can relate with example of alkene, or you can take the example of alkyne. ठीक. Now example, if I write VBT example where atomic orbital overlap is there. Suppose H2 molecule. In our H2, hydrogen is 1s1. So when they overlap, hydrogen molecule, which overlap takes place between them? That is resulting into SS overlap, and which bond is formed? Sigma bond is formed. Which bond is formed? A sigma bond is formed. So hydrogen molecule involves which overlap? SS overlap. Similarly, you can think about F2 molecule. F2 molecule, in which in valence shell it is 2s2 2p5. Two S2 2p5. And same way other fluorine also there. Now here which overlap takes place? Here which overlap takes place? PP overlap. Yes. So you will mention in F2 which overlap takes place? 2p with 2p. And it is which bond formed? Sigma bond. Why? Because we know if only one bond is forming, where two electrons are combining, one bond form. So first bond is which one? Sigma. That means it is always along the axis. So whatever axis is mentioned, if Z is there, it will be PZ, PZ. If it is mentioning X as the internuclear axis, PX, PX. So no doubt about that whenever PP is there and only one bond, firstly it will be a sigma bond. So here which orbital overlap is there? 2p, 2p overlap. Same way in HF. Which orbital overlap? 1s of hydrogen and 2p of fluorine. They combine and which overlap? Sigma bond. Why? Because whenever s orbital involved, it is which overlap? Which bond? Sigma bond. In pp, if one bond, then it is sigma. It is always along the axis, more stable bond formation. Now here we can compare bond length also using VBT. Like which example? VBT में HF, HCl, HBr, HI. And similarly for same example we can compare their bond enthalpies or bond energy also. So among them, by using VBT, how can we compare the bond length? HI more, very good, but reason also mention. Whoever mentioning it, answer you can say reason also. Yeah, it is n value not same. Acha, the n value same or not, it will affect the bond strength, but S bond with fluorine, S bond with P, one S with 2P or 3P, one bond is sigma only. Maybe bond length less or more, that's different. ठीक है. Now here in HF, 1s of hydrogen is used or not? Yes, 1s, 1s, 1s. But fluorine, which orbitals used? 2p, HCl में Cl, 3p, Br, 4p, and then 5p. So now tell from fluorine 1s with 2p. Principal quantum number is 2p. Then 3p. Distance increasing now. 4p and 5p. As value of n increases, distance from the nucleus increases or not? Hence bond length increases. So that is why the order is Hi maximum bond length and HF least, and reason is what? Already written, 1s with 5p, the distance of nucleus is increasing for the electrons in the valence shell, bond length has to be more. So as the value of n increases, bond length also increases. As the value of n increases, bond length also increases, and bond length is generally inversely proportional to bond energy. So answer is it is general term. Yes, it is correct. Generally we say this is correct, that bond energy and bond length are inversely proportional. Next example, slight twist is there. So I will firstly today explain only bond length. F2 bond length, Br2, Cl2, I2. ठीक है? In F2, which orbital overlap is there? 2p, 2p. In Cl bond, 3p of one Cl combined with 3p of other Cl. In Br2, 4p with 4p and I2, 5p orbital combined with 5p. Now tell me, where maximum distance is there? 5p, 5p. Therefore, the bond length of II bond is maximum as compared to F2. You can explain by more size. Size itself means that 5p orbitals are involved in the bond formation. ठीक है, till this point clear? Are you getting? Till this point? अब देखो, but you will not get the answer here. For bond energy of F2 is not maximum. That's why I am saying general terms are different, and wherever these general rules are not working, we should know these examples as per the syllabus. ठीक है, तो here bond energy values are not like this one. In bond energy, experimental observations are different, like Cl2, then Br2, then F2, and then I2. So write down this one. It is purely experimentally known. Experimental bond energy values will give the order. Theoretically we can explain anything. Clear? So in next class, whenever class will be there, I'll ask the reason from you, because you are at home, so you can read also. If you are not at home, so I could have discussed in class and given you. So you can give me exact reason in the next class why this is the order. Answer is this one. Bond energy is not following here. That bond length and bond energy are inversely proportional. Then we use the fact, that value factor, and then we can explain how, which is applicable for this example. Completed? Okay. Yes, those who are getting it very good. In next class, I'll start from this point. You can remind me bond energy explanation of halogens. Okay, students. Next class will be there. I'll see you soon. Bye. Take care.